So good afternoon, everyone. I am Hariom Patidar from Acropolis Institute of Technology and Research and Computer Science and Information Department, Technology Departments. So now today we are here to discuss about most important topics of the theory of computation, that is formal definition of finite automata. So now discuss about what is finite automata. So finite automata, that means ki anything which can be represent in a or feed to the machines in their own language. That means if we are feeding them in a one common English language, then it didn't understand it. So we can feed them in such order that how it can understood very well and response to that answers. This is known as finite automata. So the representation of the that means the five tuple structure, that means the form, or we can say that how we can feed the concepts to or logics to the machines, which are all covered in this five tuple structure. In these five tuple structure, these are the main there are all other modes or other things which are used for the feeding the logics, but the five tuple structure, these are the most common, and which is very necessary and always help to represent the logics for the machines. So here all these are the five automata tuples. That is, first is q, that is finite set of states. Second is sigma, that is finite alphabet. Third is delta, that is transition. Then q naught, that is start state. Then f is except state, that means we also said it final state. So we can understood one by one about all the states. So first one is finite set of state, that is q. So what finite set of state considers, it represent all possible situations or memory the machines can have, which means that if suppose in machines, in AI machines, that means the what cases or what the informations it can carry, all these are represent by making any situations which are done by these state, that is final set of state, that is first step. And then second most important point for this state, that is it must be finite, meaning the machines have limited memory capacity. That means if we didn't feed the unlimited, that means it also have a finite memory, it didn't have infinite capacity, so we can also delete something and again feed some more after deleting all the. And second one is input alphabet, that is known as sigma. So permitted symbol, that means if we are feeding something to the our machines or to logics to machines, that means it was feed it in the form of symbols, that is known as permitted symbol. The alphabet define the exact set of symbols the machine is allowed to read. that means जो अल्फ़ाबेट हमने पर्टिकुलर हम जो अल्फ़ाबेट पढ़ते हैं ABCD, वही मिलके एक पर्टिकुलर सिम्बल्स बनाते हैं, जिनसे हम क्या कर सकते हैं कि जो मशीन है उनको अलाउ करती है कि हाँ हम ये रीड कर सकते हैं। इसी को हम बोल सकते हैं परमिटेड सिंबल। दैट मीन्स कोई अलग से कुछ सिंटेक्स नहीं है कि कुछ अलग से नया हमने कुछ सिम्बल्स बना लिए, नहीं, जो अल्फ़ाबेट्स है उनको ही रिकम्बाइन करके हम सिंबल बनाते हैं, वही है, बाकी न कुछ नया सिंबल बनाए नहीं, वो नहीं है। नेक्स्ट आता है कॉमन एग्जांपल इंक्लूड बाइनरी। दैट मीन्स कि हमें पता है, वी हैव नो अबाउट बाइनरी 0 1, that the computer learn about only the binary language, it is 0 1 or any ASCII character. That means it is also done with the machines, that is or for machines for finite automata. And third is start state, that is q naught, which is also known as the first state or the initial state, which means the the initial state or the first state where the computation is begin. This is known as the start state or final or initial state. Here is the same thing I write, the state where computation begin. There is exactly one start state in every DFA, which means any definition of finite state automata, there is a single state. There is always have a single starting state. That means without the start state there is not a DFA. So okay, I think you are clear. Visualize by an arrow coming from nowhere pointing to circle. That means यहाँ पे बताया गया है कि वो कैसे रिप्रेजेंट करते हैं, तो हमने यहाँ पे देख रखा है, आप यहाँ पे देख सकते हैं ये चीज़। ये जो है डेट मीन्स एरो, डेट मीन्स कि कोई पर्टिकुलर कुछ एरो है, वो हम उसको उससे एरो से रिप्रेजेंट करते हैं। नेक्स्ट आता है फाइनल स्टेट, डेट मीन्स कि द लास्ट स्टेट, हम उसको बोल सकते हैं एज द लास्ट स्टेट नहीं, लेकिन हम समझेंगे क्या है acceptance criteria. That means कि it is not a final statement, means some peoples or some student understood that it is the final state. That means any logic which is feeded, it is actually run. Not no no, it is not a final state. It is accepted state. That means any input we are feeding to the machines, which is accepted by the machine, then this is known as final state. Not the computation done on that final state. No, it is the acceptance of that input only, this is known as final state. So we have the same thing, I write f is a subset of q containing state that signify the successful computation. That means here f is subset of q, that means q which means all the criteria which is required to fill the machine, it is a q, and f is a subset. That means f something input which are feed to that q is a subset of q. That means f is some input for q which is successfully computed. That means if we do some input in q, that is f in q which is successfully computed, that means accepted by the q, which is known as final state. That is represented by a double circle in a state diagram. Sorry, my diagram is not completely visible. So I think you are clearly understand the second point. It is represented by a double circle in a state diagram, which means if for in state diagram, if any circle, any diagram, any circles which are doubly circled, that means which is known as final state, means at which the input signals are successfully computed. The next is computation function. That it is also one of the most we can say most of the points, the engine of logic. That means it is the most point of the logic. A rule set the determine the next state based on the current state and input signal. ये एक टाइप का ऐसा रूल है जो डिटरमाइन करता है नेक्स्ट स्टेट ऑन द बेसिस ऑफ करंट स्टेट्स एंड इनपुट सिग्नल, which means I explained it. Suppose I started from some in some signals, then we have current state and some also input signals. Then this current state and input signal both combine to create or assume the next state. Okay, then this next state is will be considered as a current state, and we also have input, then these both are combined and to form another next state. So by following this define the flow of the entire computation process. That means it determine its futurely defined. That means it define first the complete flow of computation process before we doing that thing. Next is the transition formula. We have studied all the concepts or all the five automata, and this is the complete formula made from this whole finite automata. That is mm, delta q. That means it is a complete the sequence or what is the which criteria we are used for our logics into delta and arrow into q. Okay. Next आता है visual view state diagram. We have studied about all the five concepts. Now visual view state diagram, that means we are understood this concept by taking some example or real world example. Here is a diagram. This is first state, this is second state, and this is third state. And this is the arrow function. That means it is the that means it is initial state, and these are final state. Okay. The next is data view transition table. From previous answer, q naught is the start state, and we took some input that is 0. So from by taking an input 0, we are moving to the q1, and from taking input 1, we are all again move to the q naught. After q1, we also repeat this sequence, and for taking input 0, we return to the q1, and for taking input 1, we are return to the q0. That means it is the complete we also said it complete sequence or how the our diagram work, flow of the work. Next is concept strict determinism. That means the what concept we are used in our logic feeding to the machines, so it can completely or without any disturbing it work properly. First is unique path and second is no ambiguity. For unique path, we can, for every state and symbol there is an exactly one outgoing transitions, which means from any state and for any symbol there is exactly one outgoing transition. That means uh, if we are creating any state, so there is only one transition is outgoing from dead state. If we are do more than one transition, then it is wrong. Only one transition is outgoing and only one transition is ingoing on one single state. And second is no ambiguity. The machine never has to guess or choose between the multiple paths from the same symbol. That means if we are any at a single state, then the machines have no right to guess or choose multiple path from the same symbol. That means it have to move only single path, or it doesn't guess choose multiple path from single symbols. And now here analog turnstile, that means it took we took an examples of real world where it work. A mechanical turnstile gate is a simple DFA. That means there is a machine that is known as mechanical turnstile gate, which is work on the principle of DFA, state, lock and unlock, which means it has a two stroke, that is lock and unlock, and one input, that is coin and push, and last reason is transition between state. Formal checklist, we have studied all about them. And then any questions you have, then comment out down please.